Hello and welcome to this lecture on complex integration. In this video, we are going to see about problems on Laurents series. Let's begin. So, first of all, what do you mean by Laurents series? So, already we have studied about Taylor series. Now, let's start with this. If C1 and C2 are two concentric circles with the center at Z equal to A with the radius R1, R2, where R1 is less than R2. And if the given function f of z is analytic inside and on the given circles within the annular region C1 and C2, then for any z, the annular region, we can write, we can express the given function f of z into this series, where an can be written as 1 by 2 pi I integral over the C1, the concentric circle C1, with f of z by z minus a whole power n plus 1. So this is the term. This term can be written like this. And Bn will be in the form of 1 by 2 pi integral over C2 f of z by z minus a minus n plus 1 dz. Here it is n plus 1, here it is minus n plus 1. So of course it is a general form. Okay, so we shall go for the problem. You can understand better how we expand the given function. So here they have given the function f of z is equal to 1 by z square minus 3z plus 2. So this is the function and they have given one region, 1 less than mod z less than 2. So within this region, we want to express this function as a Laurent series. Okay, so first we start with this. We have to make this function a very simple. How we can make this function? The simple manner. First thing, you just take the denominator of this part and you just factorize this. While factoring this on multiplication, I have to get 2, and while doing subtraction or addition, I have to get 3. So what will be the factors here? Z minus 2 and Z minus 3. Yeah, minus 2, minus 3, minus 1 and minus 2 and minus 2 and minus 1. So if I multiply this, I will get 2, and if I add, I will get minus 3. So these are the factors. Okay. So now we can use partial fraction. How we can write this? Z minus 1 plus b into Z minus 2. And we have to find the value of a. So before that, we can make a simplified form. A into Z minus 2 plus b into Z minus 1 divided by Z minus 1, Z minus 2, and here it will be Z minus 1, Z minus 2. So these two terms will get cancelled. Okay. And then remaining will be 1, Z minus 2 plus b into Z minus 1. And if I put Z equal to 2, then I will get the value 2 minus 2, it will 0. So here it will be b into 2 minus 1, 1. So the value of b will be 1. And if I used to take Z equal to 1, 1. So what is the function we had? 1 equal to a minus. The given problem will be 1 equal to a into Z minus 2 plus b into Z minus 1. So if I substitute Z equal to 1 here, I will get the value of a into 1 minus 2 plus 0. So I will get a equal to minus 1. So therefore, we get the value. The values are a equal to minus 1 and b equal to 1. So then we can represent this as a by z. This is factorized into z minus 1 and z minus 2. So we have write in the form of z minus 2, and I may substitute the value a will be minus 1, then b value will be 1. So we have made a simplified form. In this problem, they have given a region. What is the region here? It will be of 1 less than mod z less than 2. Okay. So here we will use two formulas basically. Already we know that a binomial expression, it will be of x plus x square plus dot. Another one is of minus 1 minus x plus x square minus x cube, and goes on this way. This can be written only if mod x is less than 1. So now we want to express these two terms as a series by using this binomial formula. To use binomial formula, we want to check whether here it is x in this form z. So when we can apply this binomial expression, it should be in the form of 1 minus or 1 plus. Okay. If I bring this term to the numerator now, of course we will get power minus 1. This also, if I bring this term to the numerator, it will be of minus 1, power minus 1. So we have to rewrite this accordingly. It has to satisfy this condition, and also that should be the term 1 minus the next term should be always less than 1. So we may take this equation first. It will be of minus 1 by z minus 1 plus 1 by z minus 2. So how we can express this? Of course, this is our function f of z. I may take this region. What is the region? They have defined 1 less than the mod z less than 2. I may split this into two divisions. Mod z greater than 1. I need to check whether it is less than 1. When it will be less than 1? If I divide this on both sides, divide by 1, then I will get 1 by 1, it will be 1. And here mod z less than 2. So it has to be less than 1. So if I divide it by 2 on both sides, I will get the value 1. So according to the binomial expression, the second term x, that should be less than 1. So according to the given region, I am getting this 1 by z is less than 1 and z by 2 is less than 1. So we have to change into the form that has to satisfy the given condition. So it has to become 1 by z. So if I take z from this term, what will happen? 1 by z. And here, if I take the value, here it should be z by 2. Z by 2. Now, if I take z 2 from this term, then z by 2 minus 1 will be the resultant. So just see, here it should be z by 2 minus 1. Then I have to take the value of minus from this side, because to use the binomial expression, it should be 1 plus or 1 minus the second term. So on the next step, I am changing over this 1 minus 1 by z. Of course, it is in the right way. So now I may take minus from this term 1 by 2 into 1 by 1 minus z by 2. Okay. So on the next step, it will be of minus 1 by z into 1 minus 1 by z here plus 1. Already we put minus 1 here. So we may take minus 1 by 2 into 1 minus z by 2. Okay. So on the next step, we may take this term to the numerator. It will be of minus 1 or minus 1 minus 1 by 2 into 1 minus z by 2 whole power minus 1. Now we can use this formula. 1 minus x power minus 1 can be written as dot dot when if mod x is less than 1. So already we know that 1 by z is less than 1 and z by 2 is less than 1. So we can use this binomial expression here. So it will be of 1 plus, in the place of is x, here it is 1 by z. So 1 by z plus 1 by z whole square, it goes on this way, minus 1 by 2, and if I expand this, 1 plus z by 2 plus z by 2 whole square, it goes on this way. So now we can rewrite this. We used to um, show that series in general way, means we use summation. So here I may take, here all the values are plus. So I may take 1 by z whole power n when n equal to 0 to infinity. If I expand the series, I will get this. When n equal to 0, any non-zero value power 0, I will get 1. If n equal to 1, 1 by z will be there. N equal to 2, I will get 1 by z whole square. So in the simplified form, we can write like this. As same as I can mention that n equal to 0 to infinity z by 2 whole power n. So we have expressed the given function in the form of series. Okay, this is the final solution. So we take the function f of z and we have expressed in the form of series, that we call it as Laurent series with respect to the given region.